Hi everyone! Welcome back to IntegralCalc.com. We're going to be doing a chain rule problem today with the trigonometric function here, y equals sine cubed of x times tangent to the 4x, or sorry, times tangent of 4x. I've written the the product rule formula up here because we'll need it to complete this problem since we have the multiplication of two different terms, one being sine cubed x and the other being tangent of 4x. So the first thing that I want to do is just change the way this problem is written to make it easier on ourselves. I think it's easier. I would like to move the exponent here, cubed, out to the outside here because it's easier for me to visualize. The important thing, and the reason that it's not written this way, is because a lot of people tend to write sine of x cubed, which is not the same. Here the cubed is on the sine and here it's on the x. It's very important to write the parentheses here because that means that the whole thing is cubed versus just sine of x cubed. But I think it'll help us with chain rule to visualize because this throws a lot of people off when it's in the middle. So I'm just going to rewrite it that way, making sure to add the parentheses, and then we'll take it off later. So I've rewritten the problem. And then the next thing we need to do for product rule, for the purpose of product rule, is assign f of x and g of x to terms in our problem. So it doesn't matter which one. I'm going to go ahead and call f of x sine of x cubed, and we'll call g of x tangent of 4x. And this will allow us to keep things straight as we write out what we need to here for product rule. So this is the way that we apply product rule when we're taking the derivative. So let's go ahead and write out the derivative. Y prime, we'll set it equal to, first we need f of x, which we just leave it alone, we don't need to take the derivative. So sine of x cubed times the derivative of g of x. So in this case, I'm just going to go ahead and write out the whole problem and then we'll take the derivative later. So that's going to be times the derivative of tangent of 4x. Then we have to write g of x there, leaving it untouched, so tangent of 4x, and then multiply that by the derivative of f of x. So I'll go ahead and just write out derivative ddx of sine of x cubed. Okay, so this is us applying product rule. Now we can actually go ahead and start taking the derivative, and I wrote it out like this because we're done with product rule now, and now we can just think about chain rule. And remember, with chain rule that we're always working from the outside in, taking the derivative one step at a time, first with the outside part of the function, and then working our way in step by step. So when we have y prime here, so y prime equals, we can leave the sine of x cubed, and I'll go ahead and rewrite it the way it's supposed to be here first. So sine cubed of x, then the derivative of tangent of 4x. Well, the derivative of tangent of x is secant squared of x. So we can go ahead and write secant squared. Because we have 4x, it'll be secant squared of 4x. But that only addresses the tangent part here. Remember, we're working from the outside in. So we took the derivative talking about tangent, that was the outside. But now we're moving even further inside the function. We still have to multiply by the derivative of 4x. We can't just leave it this way. So we'll go ahead and multiply by the derivative of 4x. Again, here working from the outside in, let's say plus tangent of 4x, and then taking the derivative of sine of x cubed. Again, we will start with the outside. So because we have the cubed exponent out here, we bring that out in front, right? Taking the derivative using the power rule, we multiply by that 3 in front. 3 times sine of x, and we subtract 1 from the exponent, so we get, sorry, that's tiny, so we get a 2 here, However, we worked from the outside in, we did the outer part, but we still have to multiply by the derivative of the inside, sine of x. We can't just leave that alone. So let me go ahead and write out the multiplying by the derivative d dx of sine of x. So I hope you can see how we've been working from the outside in. Let me go ahead and erase all this stuff that we don't need anymore. So working from the outside in, we still need to multiply by the derivative of 4x and by the derivative of sine of x. So let's go ahead and rewrite this up here. Y prime equals sine cubed of x times secant squared of 4x, and then the derivative of 4x is simply 4, so we'll go ahead and multiply by 4, and we're done with that because there's nothing further inside the function. We were able to take the derivative of 4x by itself and get 4, so we're done with that, and then we add to that tangent of 4x times, let's see, 3, and we'll change this to sine squared x, which is the proper way to write it. And then the derivative of sine of x is cosine of x. And technically, we would need to multiply by the derivative of x alone, because that would be properly applying chain rule. Working from the outside, we would just do sine. Then we would multiply by the derivative of x because it's the inside. But the derivative of x is just 1, so we actually don't need to multiply by anything. It would just be redundant. So we've gone ahead and taken the derivative of everything, and the only thing we need to do now is just simplify. So I'll move this the 4 out in front as a coefficient, and I'll also be moving the 3 out in front and reordering. So y prime equals 4 sine cubed x secant squared of 4x plus, and then here we have sine, cosine, and tangent. That would be the proper order to write those trigonometric identities. You always want to write them first sine, then cosine, then tangent. So I'm going to do sine squared of x first, cosine of x second, and tangent of 4x third. And that's our final answer. So hope that helped, and I'll see you guys next time. Bye!